Okay, good morning, good afternoon, everyone. I welcome you all for the third session. For the third session, we have Dr. Rajendra Khapre, sir, who is working as an associate professor in civil engineering department at Sri Ramdeva College of Engineering and Management, Nagpur. He has completed his BE in civil engineering in 1999 from YCC Nagpur. He has completed his ME in civil engineering in 2001 from BITS Pilani. He has completed his PhD in 2006 from BITS Pilani in the field of application of parallel computing in finite element analysis. Dr. Rajendra Khapre has 20 plus year of work experience in the field of teaching to undergraduate and postgraduate course. He is approved supervisor of RTM Nagpur University for PhD and also supervising PhD scholar in the field of civil engineering. He has supervised more than 30 MTech theses and 10 BE projects. He also a number of Institute of Engineering India, Indian Society of Technical Education, and Associate Consulting Civil Engineer. Dr. Rajendra Khapre has about 50 plus paper in the credit that includes publication in the journals and conferences of national and international reputed journals. He has received grants from AICTE, MUHS, SERB, and DST for research. He has three copyright in his credit. He has also obtained one patent in the field of biochemical engineering as well as civil engineering. He has traveled many countries for paper presentation and also served the technical session chair for international conferences. He has delivered expert lectures in various STTPs and FDPs in the area of finite element. He is also actively involved in consultancy work. Sir has expertise in finite element analysis. He is well conversant with software like ANSYS, STAAD.pro, SAP. He has also expertise in various programming language, including C, Fortran, MPI, Python, and develop programs that have copyrights. Uh, Without further ado, I will ask Sir to start his presentation. So you can start your presentation. Okay.
Yeah, thank you, sir. So let me thank you, organizers, for giving me an opportunity uh, to deliver a talk on this particular topic. So let me share my screen once again. Yeah, yes. So I think we are live. Today I'm going to talk about the various application softwares which are very frequently used in the field of civil engineering for different purposes. Now, the key areas in which the programs are available as far as civil engineering is concerned, the very first key area is your drawing and detailing. Then another key area is your planning. Then we have hydraulics engineering, then soil engineering, structural engineering, of course. Then lastly, the new area like image processing and survey, and not but last but not the least, the various programming languages which are nowadays used for developing the programs. Now, when we talk about various softwares which are used in the civil engineering, the first software comes into everyone's mind is the AutoCAD. Now, this AutoCAD was developed by a company called as Autodesk, and if you Google, you will find that the first version of AutoCAD was possibly available for the world to use in year 1980s. So you can imagine this software has got a history of 50 years. So initially, this software was developed for civil and mechanical engineering to uh, prepare the technical drawings, and now you can see this has improved a lot, and we can do many things out of this AutoCAD software. We are fortunate enough that this particular software is free for every student and educator. All you have to do is go to their website, that is www.autodesk.in, and there you can download it. I'll show you some of the slides where you can download it. Before that, this AutoCAD is basically CAD software, that is computer aided design and drawing or drafting. and it is basically used by the initially it was used for mechanical, electrical, and civil engineering. Then later on, it has started used by the architects and aeronautical engineers and many other disciplines. Now, accurate drawings, technical drawings can be drawn using this AutoCAD, and the older version was used only for preparing drawing, but the newer versions now we can have even the 3D models, and we can even have the rendered views of this three-dimensional objects. So I don't have to tell much because everybody is well conversant with the AutoCAD software. This is the typical interface of the latest version of AutoCAD, and we can see this is a 2D drawing of a building, and we can have even the isometric view, which you can see on the left hand side topmost figure, and the rendered view can be seen on the right hand side bottommost figure, which is prepared in the AutoCAD. So now to get this AutoCAD, you just have to go to autodesk.com, and there you just have to go for sign in. And once you sign in, you will get one sign in option. You create your account using your own college ID or maybe even personal ID. And once your ID is approved, you have to upload your ID card also. Your institute ID card has to be uploaded, and once your id card is approved, you can access many of the softwares which are freely available for the students and for educators. So here there you will find the download software, and once you will go to that particular window, you will be navigated to a software download window where you can actually download the AutoCAD software, different versions, maybe 2022, 23, or maybe even older version. And this particular version is uh, available only for a couple of years, and after a couple of years you may have to uninstall it, and you can install the latest version of your AutoCAD software. So this particular software is very useful for civil engineers, and I'm sure most of you are comfortable with this. Those who are not, they should learn this particular software. Now, the elder brother of this AutoCAD software is Revit. Now, this is also a software which is developed by a company called as Autodesk, and nowadays it is becoming very famous because it is a beam based software. We can have a 3D imaging, and we can have activity which are bidirectional activity which are associated in this Revit software. We can even do a parametric modeling, and instantaneously we can get the revised views. Like for example, if any of the activities revised or changed, the entire process is instantaneously revised. Now, what is Revit? I'm sure everybody is aware of this Revit. So Revit architecture is a robust architecture design and documentation software created by Autodesk for architecture design and the building profession. So like I said earlier, it works on a platform of BIM, that is building information management. Now in this figure you can see there are various activity that are combined under one roof, that is construction documentation, maybe conflict detection, and many more, 3D visualization, virtual building projects. All these are combined into a single software called as Revit architecture. Now, apart from this, there are some popular softwares which are related to project management. One is the MS Project, and second one is the Primavera. Both the softwares, they purpose on they solve almost a similar purpose, that is a managing project. If you talk about the MS Project and Primavera, they are basically a project management software. So it can be a construction project, it can be even small project or even a big project. So if I talk about the Microsoft project, so like I said, it's a project management software, and it is developed by a company called as Microsoft, and it is designed to assist the project manager in developing the plans, assigning the resources to the task, tracking the process or the progress, and managing the budget, analyzing the workload, and so and so. Now, the Primavera also works on the similar platform. Like for planning the project, what you have to define the goals, develop the task, establish the timeline, and resource availability and organized. And accordingly, these the project timeline is uh, defined. Now coming to the other area, that is the hydraulic engineering. Now, for hydraulic engineering, like Bentley has a bunch of softwares, starting from the WaterGEMS, WaterCAD, WaterHammer, SewerGEMS, SewerCAD, Civil Storm, StormCAD, PoundPack, and Culvert Master. These are under the umbrella of Bentley, and there are other softwares like EPANET, Branch, Sewer, and Loop. These are the older versions of hydraulic engineering softwares, but nowadays most of the time we'll find in the field WaterGEMS and SewerGEMS. They are very frequently used for the development of the uh, water pipeline. Let us talk about the WaterGEMS. So WaterGEMS, like I said, it is developed by a company called as Bentley, and it is widely used for hydraulic modeling, especially the water distribution system, and it has got a advanced interpolability. And then we can plan the water distribution system right from small village to a large city using this particular software. Now, this particular software is a very good interface, and it has got a good integration with other softwares like your AutoCAD is there. Even it has got integration with ArcGIS, even with a MicroStation also. This can be integrated where you can have some data taken from all these softwares, and it can be analyzed in this particular WaterGEMS software. The next area is the soil engineering. In the soil engineering, Plaxis software is very popular, and Plaxis software has got two options. One is the 2D software, and Plaxis 2D and Plaxis 3D. Unfortunately, this software is very expensive. Initially, this software was a property of Plaxis itself. It's an independent software, but recently Bentley has acquired this particular software. So if you want to purchase this, definitely you can purchase it from the Bentley, and it has got a very wide range of applications as far as the soil engineering is concerned. Apart from this Fluxys, we have another software called as a Geo5. So Geo5 is a bundle of very small modules, you can say. So there are on your screen, you can see there are 9 modules which are coming under the Geo5 solutions. That is the stability analysis, shallow foundation, tunnel. Then we have excavation design, deep foundation, geotechnical survey, walls, then settlement, then field test, and so on. Just to have a glimpses of the software, let us talk about this excavation. So whenever you want to do some excavation, you have to go for the design of sheetings. So in this particular software, you can actually design the sheeting, and you can work on the excavation part. Then there is a slope stability and stability module. So here, needless to say that whenever you are going for a earthen type of a dam, or especially the gravity dam, in that case the stability plays a very important role, and that stability can be analyzed easily with the help of this particular software. Then we have a foundation. So this foundation Geo5 foundation module is capable of analyzing and designing the pile, then pile cap, then pile as a group, then slab and raft, and so on. Then the retaining module of this Geo5 is capable of analyzing and designing the cantilever walls, gravity walls, gabion walls, and masonry walls, and so on. So you can see in this picture a typical retaining wall, which was designed using this software. Then this reinforced slope can also be designed using this particular feature. MAC wall is one of a type of wall which can be seen in this particular picture. Then the settlement analysis, of course, due to uneven loading or maybe uneven properties of the soil, there is a possibility of settlement. So this settlement analysis can also be done using in this particular model called as settlement analysis of the GeoFile. Now, the most popular softwares which are used in civil engineering are the structural analysis and design softwares. There are many softwares which are available in the market, and every software has got its own features. And to name a few, we have SAP, then STAAD.pro, MIDAS, and ETABS. These are four popular softwares which are used in India as well as in the abroad. Now, if we talk about SAP, that is the SAP stands for the Structural Analysis Program, which is developed by a company called as CSI. This particular software has got a capability of analysis as well as design of various concrete structures as well as steel structures well within the permissible limits, and that too as per the latest IS codes. STAAD.pro, yes, of course, STAAD.pro. Everyone knows what is STAAD.pro. STAAD.pro has got a very long history over the world. Initially, this STAAD.pro software was developed by a company called as Research Engineers, and during those days, the software safety was given by a company called as Bentley in terms of a hardware lock. And later on, this Bentley company has acquired the STAAD.pro, and slowly Bentley has acquiring many of the civil engineering softwares. So in the coming slides, I'll show you what are the softwares which are available under the umbrella of Bentley. To talk about STAAD.pro, the latest version of STAAD.pro is the Connect edition. The previous edition was STAAD.pro V8i, and this particular software is very widely used over the entire world. It supports many of the standard codes, including the steel code, and then of course RCC code. Apart from that, in some worlds, some of the countries like aluminum is also used, so aluminum code and timber codes are also available. So with this software, you can design any building using any of the codes, like maybe the Australian code or maybe American code. All those codes are included in this particular software, and this software has got a very good interface. And there are many videos which are available under the Bentley Learn platform. I'll show you all those things in the coming slides. Another software which is Midas, and this Midas software is mostly used in India. This is also a very good software, and it is also giving you good results, correct results, and it is widely used in the regions like Mumbai and Delhi. Then we have another software called as ETABS. So ETAB is also developed by a company called as CSI, and the SAP and ETABS they follow almost similar interface. So if you know SAP, definitely you can work on ETABS very easily, and ETABS gives you very good results as far as building design is concerned. Whereas as far as STAAD.pro is concerned, for STAAD.pro you can do almost anything. So for building design, definitely I'll recommend this ETABS, and this ETABS is very popular in India. Abroad, not that so much, but ETAB is nowadays getting very popularity as far as building design is concerned. Now, this is all about the typical RCC or maybe steel analysis and design. And when we come to a special structure, we have to use a method called as finite element analysis. Now, in finite element analysis, there are many softwares which are available. Even in the STAAD.pro also, there is a module of finite element analysis, but it has got a very, very limited capabilities. To have a very detailed analysis, you have to use finite element analysis, and there are plenty of softwares like Lusas is there, Abacus is there, ANSYS is there for advanced structural analysis. So I'm comfortable with ANSYS. So let me share some of the best feature of ANSYS, and most of the features are available in other softwares also. Now, like any of the finite element analysis, we have to give certain process, like we have to define the elements, we have to define the real-time constants, geometry, material properties, meshing, and then we have to solve the problem. So this is a typical structure of any of the finite element analysis program. Now, as far as ANSYS is concerned, and even some of the other softwares also have these capabilities, that it can do the static analysis, dynamic analysis, harmonic analysis, fatigue, electromagnetic, seismic, and many more features. I am just highlighting 6 features over here, but ANSYS has got different features also. Now, the ANSYS has got a capability of analyzing multi-physics problems. So multi-physics problems means it can do the static and dynamic analysis at the same time, then static with thermal, static with fluid, dynamic with electrical. So combinedly, the analysis can be done over here. I'll give you one of the example over here in the coming slides of MEMS, that is micro electromechanical analysis. Then there are different analysis and simulation tools which are available in the ANSYS software, like design model is there, meshing feature is there, design exploration, and many others are there. Okay. These are the some of the softwares which can be easily integrated with the ANSYS. Like CATIA is there, Pro is there, Parasolids are there. So where you can create your own geometry and it can be it can be imported in this ANSYS software, and definitely we can do further analysis using this. Now, typically, when we talk about the analysis, we mostly talk about linear and elastic analysis, where the material is usually considered as elastic and the behavior of this material is linear. But there are many different material behaviors which are available, which we may have to deal with when we are doing research, when you are solving a research problem, like viscoelastic material behavior may be rigid, perfectly plastic, viscoplastic, hyperelastic, thermal. So all these material behaviors are available in the software called as ANSYS. Now these are some of the finite element analysis which are done using ANSYS. So here you can see this is a reinforced concrete tunnel, and you can see on the yellow side that's a rock, and then we have a pink color, that's a different soil, blue color it's a filling, and the white color is the concrete. So different material properties, they are analyzed in this particular feature. We can even analyze a segment of bridge individually, as well as the segments are joined together, and then we can have the analysis under the moving load. We can even have the soil analysis in this particular software. So like in Geo5 we can do this analysis, the same can be done over here. There are different soil models which are available in this particular software. Using different soil models, like Moore Coulomb model is there. So in this Moore Coulomb model we can have the pressure distribution under the foundation. So this is one of the example. Some of the interesting features of the software, that we can have a shape optimization, wherein you can optimize the shape, or we can reduce the mass of this particular plate. So on the screen you can see this is a plate which is typically joining a column and a member. So ideally, when we apply load, it looks like this, but this much size of plate is not at all necessary. So we can provide a shape which is something like this, where the corners of the plate are removed, and by which you can have the optimized cross section, which will result in reduction in the weight of the structure. So let me share you one more view. So here you can see this could be the actual plate. We don't require the entire square plate. We can even have a shape which is something like this. Okay, so we can have a plate something like this, and the corners can be removed, but still your structure will be safe, but your the weight of the structure will be reduced. Then we can even analyze complex structures like castellated beams, where we have a steel section and there are some openings which are made to pass some of the ducts of pipeline or maybe a water. And IS code does not give you a design procedure for such type of members. So we can have a different, we can have a analysis of this, and we can see how the structure is behaving. Then we can even model the reinforcement in this particular structure. So on the left hand side we can see there is a beam which is having no reinforcement, and since there is no reinforcement, the stress at the top and stress at the bottom in the concrete beam, it will be same. And as you know that concrete is weak in tension, so it will tend to break. But if you, in the same model, if you apply the reinforcement which is there on the right hand side, so there you can see the stresses which are there at the bottom, they are significantly reduced because the tension is taken care by the steel. And you can see there is a significant amount of reduction in the stresses. So So you can immediately see case A, that is without reinforcement, and case B is with reinforcement. And you can definitely see there is a significant amount of reduction in the deflection also due to the imposed load. Then some of the special cases like cantilever beams, these are the deep beam, I should say. Especially in case of deep beam, what we have observed that the maximum amount of shear, usually it is considered that the maximum amount of shear is coming at the support, isn't it? But if you consider the deep beam, definitely you will find that maximum amount of shear, the location has been shifted. So this analysis is possible only using a finite element package. Now, if you want to analyze a complex shape like a rail fish plate connection, the one which is shown in the silver color. So this is a typical plate which is used to join the two rails, and due to the influence of load, definitely this will be subjected to high amount of stresses. And typically there are three types of fish plates which are nowadays used in the Indian railways. So all these are modeled separately. Like on the over here, we can see this is the rail, this is the fish plate, every nut is there, and this is the complete assembly. And this was analyzed for the moving load of the standard axle of rail, and you can find there is a deformation pattern over here, and here you can see the deformation is larger at the joint. Uh, then this is a typical comparison of all three fish plate, and you can see both or the all three fish plate, they perform similarly. Now another interesting part is the thermal analysis. Now whenever we are going for the mass concreting, where mass concreting means where the depth of the concrete at the time of casting is probably zero point 0.5 meter and higher. So during this case, what happens, because of the huge amount of concrete in the because of the huge amount of concrete, the heat of hydration which is generated is also very very large. Now this heat of hydration is going to create a lot of trouble because it is going to crack the concrete in the initial stage, and ultimately it may result into a failure of the structure. So here we have done the thermal analysis using the software called as ANSYS, and as you can see, as the concrete hardens, the temperature inside the structure, it is increasing very rapidly. So right from, if you look at the central picture, the outside temperature is 24 degrees and inside temperature is 47 degree. So this is almost a double temperature, and because of this huge heat, there is a possibility of cracking of concrete in the initial ages. So we have to provide sufficient uh, provision for the water inside the body so that the temperature can be controlled. Now, this study can be done for different types of shapes, because different shapes will cause the maximum temperature acting at different locations. So, if you know the locations, so definitely we can put a pipe over there, and we can supply cold water so that the temperature can be done. Now, another analysis is the thermal analysis of the building, and this is one picture you can see where the building is completely modeled in ANSYS, and it was analyzed for 24 days. And you can see there is a significant difference, roughly 8 degrees temperature difference is there inside and outside the building model. So you can study this, like for example, if you are providing a insulation on the northeast side wall, or maybe you are providing a insulation on the roof, what will be the temperature variation inside the room. So accordingly you can design the insulation, where has to be kept, what should be the thickness, and the temperature can be controlled. So this type of analysis can also be done in this software. Now, mostly we are dealing with a material which is linear and isotropic in nature, but sometimes we may have to deal with a orthotropic material. So orthotropic material means what? The material properties of the given material is different in x direction, it is different in y direction, and it is different in the z direction. Now, the best example of such type of material is ply. where the fibers of the material, they are not in the same direction, they are layered, and the direction of that particular fibers, they are different for every layer. So like in this picture, the green ones, they are showing the 0 degree, and the white one, they are showing the 90 degree. And definitely the orientation of these fibers, whether it is in parallel to X or parallel to Y, this is going to change the entire behavior of the structure. Now, uh, what we have done, we have just carried out a simple study wherein the different sequence of the fibers are oriented, and the stress strain behavior will be not the same as what we usually see. And this is a typical analysis which shows the deformation, shear, and shear stresses. Now, from this picture, you can see if we orient the fibers in the 45 degree, minus 45 degree, 0 degree, and 45 degree, then you are getting the least deformation. So this particular combination, that is the third from the last, this is going to give you least deformation. So this is much better. So unless and until you do this analysis, you will never come to know what kind of orientation is suitable for you for the given problem. So such type of analysis can also be done over here. Now, usually we talk about a linear analysis where the stress strain curve is linear, but in most of the cases, especially in case of failure analysis, we may have to cross this linearity, and we may have to we have to enter into the domain of non-linearity, where the stress and strain, they are no longer proportion to each other. Now on this screen, you can see this is a typical stress strain curve for a steel, where the linearity is there up to yield strength. Then there is a reduction in the strength, and then there is an increase, which we call it as ultimate strength, that is point D, and at point E, it is going to fracture. Now, this is a typical representation of the finite element analysis of a bar, which is stretched until and unless it breaks. Okay, so this is a typical example of a non-linear analysis. Now, another non-linear analysis is this one. So here you can see this is a typical beam, which is fixed at both ends, and it is subjected to a concentrated load. Now, once it is subjected to concentrated load, under the load, there will be a plastic hinge form. And this plastic hinge is going to create stresses which are beyond the yield stresses, and there will be a permanent deformation at that particular point. But as far as the other part of the material is concerned, it will be in the elastic limit. Now, this is the typical material behavior under the nonlinear, especially when we talk about the crushing. So here you can see this is a rectangular tube which was crushed, and it has become a shape of 8. This is a circular tube, this is crushed, and this circular and rectangular tube, it is crushed vertically. Okay. Another example is the residual stress. Like I said, if you take a simple cantilever beam, if you apply a load, if you remove the load, it will go back its original position. But after certain magnitude of load, it will permanently bend, and some amount of stresses which will be introduced in that particular cantilever plate, and it will remain there, and it will not go back to its original position. That's what we call it as a residual stress. So we can definitely analyze the residual stresses also by using the material nonlinearity option. This is what I was talking about, that is micro electromechanical system, that is MEMS, and this is the perfect example of multiphysics. Now, what happens in multiphysics is there are three problems combined in this case. So this is a bar which is having two different metals. The bottommost is the copper alloy, the top one is the aluminum alloy, and there are three locations, that is A, B, and C. And at A, we are applying a basic temperature of 30 degree, and at B and at C, there is a difference in voltage. Now, especially in case of your electronic gadgets like your cell phone, there is a huge amount of voltage fluctuation, because at certain point, at one corner there will be a voltage, and other corner there won't be any voltage. So this difference in voltage at two different location is going to create the rise in temperature. So here the input is voltage, but the output is rise in temperature. Now these are two different things. Voltage is the electronic part, and the temperature is the thermal part. Then, due to rise in temperature, there will be expansion of the material, and due to expansion, there will be a stresses. So here you can see we are dealing with three different physics. One is the electronics, then there is a thermal, and there is a structural. That's why it is called as a multi-physics problem. So such type of multi-physics problem, like electronics, change in voltage causing temperature causing the deformation. So this combined effect can be studied into a finite element softwares. This is also this is the actual variation in the temperature due to the difference in voltage, and this is the variation in the deformation due to the increase in voltage. Now, this finite element analysis is not only limited to the structural, thermal, and electrical, it has entered into the world of biomedical engineering also. Many of the biomedical implants can be designed perfectly if you do the finite element analysis correctly. Now, the simple example is your tooth cap. So, if you have a tooth cap model available with you, definitely you can go for the structural analysis of this tooth cap, and you can see how it is. I mean, whether it is able to sustain the given loading or not. That can be easily analyzed using a finite element software. Then another example is your bones, like especially in some of the accidental cases, the bones are fractured. Sometimes you may have to replace the bone, and sometimes you may have to go for the attachment of plates. So we can have the analysis of this attachment of plates, and maybe a dynamic analysis using the ANSYS for the newer bone, and we can see how this bone is going to distribute the stresses over the body. Another part is the impact analysis. So this is one such example where you can see a ball is bouncing on a simple plate. There is nothing new in this, but with every bounce, the force which is acting on the plate, it is reducing. For the first bounce, the impact will be more. The second bounce, the impact will be less and less and less and less. So this impact load is going to create a lot of trouble, especially in case of accidents. So you just imagine some construction is going on, and some construction material, heavy material is falling on the slab. So although your slab is designed for certain load, but due to the impact, this load is increased tremendously, and you may find there is a damage in the slab. So such type of analysis can be done, and we can see whether the slab will sustain the external loading or not. Apart from this, we have a buckling problem. So for example, if you see this particular column, so under the application of the vertical load, it should behave like this. It should compress axially. But in practice, actually, it starts buckling because there is a difference in the moment of inertia along x-axis and y-axis. So in place of compression, axial compression, you will find there is a buckling. So these are the real life problems which can be analyzed over here. Another example is the buckling of the I section. So ideally the I section, it should behave like this, but actually it is behaving like this. This is what we call it as a buckling. Another example of buckling is your cantilever. You can see the cantilever, they should behave like this under the given load, but in real life the I section is behaving like this under the application of load. It will tend to buckle after certain amount of load. So this buckling behavior can be analyzed easily using this finite element package. Now, earthquake analysis, yes, of course, STAAD.pro, ETABS, and everything is okay. But here also you can have the analysis which is subjected to the earthquake loading. So we just have to give the proper input, and we can see the structure dancing on the various frequencies. The most important part is the modal analysis. So in the structural dynamics, you might have studied there are different types of modes. So here, this is the second mode. It is moving in the vertical. Then this is the third mode. Then we have the fourth mode, which is twisting. And then we have the fifth mode for the different frequencies. You can easily get different types of mode for the given structure, and this particular modal analysis is very useful in the harmonic analysis. So harmonic analysis, you can see this is a typical plate which is moving in the vertical and vertical direction. And then the second mode shape is like this. So basically what happens when the frequency of the load and the frequency of the structure it matches, the resonance is going to create. And due to the resonance, the deformation which is caused due to the external loading, it is increased tremendously in case of the resonance. So we can actually do this analysis, and we can find how much resonance is there, how much, what is the natural frequency, and what will be the maximum deformation under the especially in case of resonance for different frequencies. Now, this is something new because till now we were designing the buildings for different types of loads, maybe self-weight, then live load, then maybe a thermal load, maybe a wind load, earthquake load, so and so. But nowadays, this impact load, especially due to the explosion, it is coming into picture. And this can be a, disaster like the Beirut explosion, or maybe a man-made disaster, maybe a missile explosion. So let me play this video for you. So here you can see there was ammonium nitrate which was stored into a storage facility, and which got exploded due to the fire. So this event, I think it has happened during the COVID period, probably in 2021. This explosion has happened, and entire world has witnessed this particular explosion. And the amount of explosion was such that the many of the buildings which are there in the Beirut city, they are destroyed. So let me show you another video, so that in this here you can see the effect of wave. You just imagine what could have happened in the building which is next to that particular storage vessel. And you can see, yeah, you can see there is an actual wave which is going due to the explosion. So we can do this analysis in the softwares. May not be in ANSYS, but maybe in Abacus. So this is a simulated version of that explosion. So you can see the entire city was modeled, and the damage assessment was done due to this explosion. Now, for this purpose, we need to understand the CFD simulation, that is computational fluid dynamics simulations. And the simplest example of this CFD is your AC. So now you can see there are two rooms, one is on the left, one is on the right. And here you can see AC is installed on this particular corner, and here the AC is installed on this particular corner. So we, with the help of CFD analysis, we can locate the location of your air condition, and you can see which location is best suitable to cool your room quickly. So here the concepts of CFD comes into picture, and we can do various analysis using the fluid, because air is also considered as fluid. So this is one of some such example. Now, the important part is the reality modeling. This is something new. Now, whenever you want to do analysis on the real life problems, you have to create the 3D model of that real problem. Now, there is one such software called as context capture, which was developed by Bentley. Now, how this software use is you have a specimen or a building. So what you can do, you can create a pictures of that building or maybe a specimen from different angles like A and B. You can see over here. Now this software, what it will do, it will stitch that picture, and it is going to create a 3D model out of it. So this is one 3D model which is created by a Bentley. So by contest capture, and here you can see with the help of drone or maybe a helicopter, various pictures are taken of the entire city, and all those pictures are stitched together, and a 3D model is created. Now the best advantage of this 3D model is you get the correct elevation, correct dimensions of the entire structure. And the same thing can also be done into a software called as ArcGIS. Now this is very much essential, because nowadays like Beirut explosion can be simulated unless and until you have the correct model of the entire building. It is really difficult for us to simulate that. Now, apart from that, Bentley has got different softwares. Like I said, Bentley is the leader in various civil engineering softwares. So they are categorized under the bridge analysis, probably bridge design. Then we have civil design. There are different packages. Then hydraulic and hydrology. This I have already explained. Then mine design, modeling and visualization. Then offshore analysis, plant design, and the reality modeling. Okay, and of course the structural analysis where STAAD.pro, STAAD Foundation, Pro Steel, everything comes into picture. Now, like I said, Bentley offers many civil engineering softwares. So, how to learn them? The simplest way is you go to the Bentley website, that is education.bentley.com. There you will find there is a login symbol. You just have to create your ID over there, and once your ID is created, you can directly go to the window of students and you can say get training. And once you open that, you will find there are trainings which are related to various softwares, even on STAAD.pro, then WaterGEMS and many more. And you complete that training and you will get a certificate also. All you have to do is just you have to go to Bentley softwares, and you just have to register yourself and you have to upload your ID card. Once you upload your ID card, you will find your the testimonials whatever you have provided, it will be checked, and then you can easily download a free version of the software, and then you can learn these softwares with the help of the uh, videos which are available on the Bentley website. Now the last part, that is the programming part. Now what I talked about over here till now are the basic softwares. Now why to use the software? We can develop our own softwares. Nowadays, like when I was doing my graduation, that time only C and Fortran was there. But nowadays we have a very good programming language called as a Python. So let me quickly show you some of the Python programs. So here you can see this is a simple Python program which was developed by few students, and you can see it is very much similar to your C program. It's a lengthy program, but if you look at the output, traditionally what is expected from the program is the text output, that what is the riser, what is the trade, and what is this and what is that. But apart from this, Python has got a very good ability, and if you write it correctly, then it will show you the actual drawing also. So you don't have to rely on the text output, so that you have to read the text, you have to understand the text, and then you have to reproduce the drawing. But if you look at these pictures, so these are the output of the program. Here you can see this is the design of grid chamber. Okay, so this is the text output which you traditionally get in any of the programming language, maybe a C or maybe Fortran. But in case of Python, you will also get the drawing also if you do the drawing part also. This is one such example, that is the design of bar screen. These are very small programs, and here you can see this is the text output, design of bar screen, and this is the pictorial output. The beauty is you just right click on this and you can even copy the image and you can paste it in any of the report. Okay, even this report is printable. All these images, they are easily printable. Now this is the most economical channel section. This can be a triangular, and there are many other, okay, rectangular. So all these things is really possible with the help of program. So there are many courses which are available in the Coursera platform, and even NPTEL also. There are many software, many courses which are available, especially on the AutoCAD. There is a course on Coursera. I'm sure you will find it. Please join them and learn the softwares, and definitely it is going to help you a lot in improving your careers and in understanding the latest trends which are there in the civil engineering. Okay, so thank you very much, sir. Are there any queries? We can have some small question and answer session if required. Yes, sir.
Hello. Hello.
Yes, sir.
Uh, I would like to thank Dr. Rajendra Khapre sir for giving his valuable time to us. Okay. Thank you, sir, so much.
Thank you, sir. Okay, fine. If there are any queries, please let me know. I'll answer them via email or via on WhatsApp.
Okay.
Okay.
I will be sharing the feedback link in the chat box. So
Sure,
if you
sir.
have
Sure.
any query related to the topic, you can ask over there, and we will mail it to Rajendra Khapre sir, and he will revert you back on that.
Okay, sir.
Okay. Thank you so much, sir.
Bye bye.
Bye.